Imagine holding a grain of sand between your fingers. Now imagine that grain of sand is Earth, and everything you know, everyone you love, every mountain and ocean and city exists on that single grain. That is how small Earth really is compared to the universe. And today, we are going on a journey that will change the way you see everything. Before we zoom out into the cosmos, if you enjoy these perspective-shifting journeys through space and time, please hit that like button and subscribe to Cosmic Drift. It truly helps us bring more of these calming cosmic explorations to you. Now, let us begin our journey outward, step by step, watching Earth become smaller and smaller until it nearly vanishes. We start right here, standing on Earth itself. Our planet feels massive. If you wanted to walk around the entire equator, you would need to travel about 24,900 miles. That is roughly the same as walking from New York to Los Angeles 9 times in a row. Most people spend their whole lives in just one small corner of this giant ball of rock and water. You might visit a few countries, maybe cross an ocean or two, but you'll never truly grasp just how big Earth is by standing on it. From down here, Earth seems endless, but we are about to leave the surface. Imagine lifting off the ground and rising higher and higher. First, your city shrinks below you. Then your whole state becomes visible. Keep rising, and soon you can see entire countries stretched out like maps. And then, something amazing happens. You break through the atmosphere and enter space. Suddenly, you are looking down at the whole planet floating in the black void. From up here, Earth looks like a beautiful blue and white marble hanging in darkness. You can see the swirling clouds, the vast oceans, the brown and green continents. It is breathtaking, but it is also the first moment you realize something important. Earth is not as big as it seemed. In fact, it is just one small world in a much larger neighborhood. Let us start comparing Earth to its neighbors. The closest planet to us is Venus. Venus is almost the same size as Earth. If Earth were a basketball, Venus would be just slightly smaller, maybe like a volleyball. So Venus does not make Earth feel small. Neither does Mars. Mars is only about half the size of Earth. It is like comparing a basketball to a soccer ball. Mars looks tiny next to our world. These rocky planets, the ones closest to the Sun, are all pretty similar in size. Earth fits right in with them. But then we look farther out, and everything changes. Jupiter is not like the other planets. Jupiter is a giant. If Earth is a basketball, Jupiter is one of those huge exercise balls you see at the gym. In fact, you could fit more than 1,300 Earths inside Jupiter. Imagine trying to picture that. Stack 1,300 Earths together, and they would all disappear into Jupiter. It is not just bigger than Earth. It is bigger than all the other planets combined. When you see Jupiter through a telescope, you can make out its swirling storms and thick cloud bands. One of those storms, the Great Red Spot, has been raging for hundreds of years. That single storm is bigger than our entire planet. Think about that. A storm on Jupiter is larger than Earth. Suddenly, our world feels a little less significant, and Jupiter is not even the biggest thing in our solar system. That title belongs to the Sun. The Sun is the true giant of our neighborhood. If you could line up 109 Earths side by side, they would stretch across the width of the Sun. But that is just the width. If you wanted to fill the Sun with Earths, you would need about 1.3 million of them. Imagine trying to count that high. 1 million Earths. That is how much bigger the Sun is than the planet we call home. From Earth, the Sun looks like a small glowing circle in the sky. But that is only because it is so far away. In reality, the Sun is an enormous ball of burning gas, and Earth is just a tiny speck orbiting around it. Now we need to talk about distance, because size is only part of the story. The real shock comes when you realize how far apart everything is. Earth orbits the Sun at an average distance of about 93 million miles. Scientists call this distance one astronomical unit, or AU for short. It is a useful measurement because our solar system is so big that regular miles start to feel meaningless. Saying that Neptune is 2.8 billion miles from the Sun does not really help you picture it, but saying Neptune is 30 AU from the Sun gives you a sense of scale. It is 30 times farther from the Sun than we are. Let us think about what that distance means. Light travels at 186,000 miles per second. That is fast enough to circle Earth more than 7 times in 1 second. Yet even at that incredible speed, light from the Sun takes about 8 minutes to reach Earth. So when you step outside and feel the warmth of the Sun on your face, you are actually feeling sunlight that left the Sun 8 minutes ago. If the Sun suddenly disappeared, we would not know it for 8 minutes. We would keep seeing it in the sky, keep feeling its warmth, until that last bit of light reached us. Then everything would go dark. Now imagine traveling to the outer planets at the speed of light. To reach Jupiter, light takes about 43 minutes. To reach Saturn with its beautiful rings, light takes about 80 minutes. To reach Neptune, the farthest true planet in our solar system, light takes more than 4 hours. These distances are almost impossible to comprehend. And remember, light is the fastest thing in the universe. Nothing can move faster. So if you tried to travel to Neptune in a spaceship, it would take decades, even with our best technology. But the solar system does not end at Neptune. Far beyond the orbit of Neptune lies a region called the Kuiper Belt. This is a vast ring of icy objects, leftover pieces from when the solar system first formed billions of years ago. Pluto lives out here, along with thousands of other small frozen worlds. The Kuiper Belt stretches from about 30 AU to 50 AU from the Sun. That means it is 50 times farther from the Sun than we are. Light from the Sun takes almost 7 hours to reach the outer edge of the Kuiper Belt. At this distance, the Sun would no longer look like a bright, warm disk in the sky. It would look like a very bright star, but just a star, and we are still not at the edge. Beyond the Kuiper Belt, even farther out, lies something called the Oort cloud. The Oort cloud is a giant spherical shell of icy debris that surrounds our entire solar system. Scientists believe it starts at about 2,000 AU from the Sun and stretches out to maybe 100,000 AU. Let that sink in for a moment. The Oort cloud might extend 100,000 times farther from the Sun than Earth is. Light from the Sun takes more than a year and a half to reach the inner edge of the Oort cloud, and it could take almost 2 years for sunlight to reach the farthest parts. This is the true boundary of our solar system. This is where the Sun's gravity finally becomes too weak to hold on to anything. And the Oort cloud is almost entirely empty. It is just a few icy rocks scattered across an unimaginably huge volume of space. This is our neighborhood. This is our solar system. A massive bubble of mostly empty space, held together by the gravity of one star. Standing on Earth, looking up at the night sky, you see stars, lots of them, thousands of tiny points of light scattered across the darkness. Each one of those points is another sun, another star like ours, burning with nuclear fire. And the closest one to us is called Proxima Centauri. Proxima Centauri is about 4.24 light years away. Now, here is where things get truly strange. A light year is the distance light travels in 1 year. Remember, light moves at 186,000 miles per second. In 1 year, light travels about 5.1088 trillion miles, so Proxima Centauri is roughly 25 trillion miles away from us. That number is so large it barely means anything to the human brain. You cannot picture 25 trillion miles. No one can. But here is a way to think about it. If you left Earth right now in the fastest spacecraft ever built, it would take you about 70,000 years to reach Proxima Centauri. 70,000 years. Humans have only been writing things down for about 5,000 years. Civilization as we know it would rise and fall dozens of times before you arrived. And Proxima Centauri is the closest star to us. The next closest star is a little farther. Then the next one is farther still. These stars are scattered through space like islands in an endless ocean. There is so much emptiness between them, so much darkness. If you were floating halfway between our Sun and Proxima Centauri, you would be in the loneliest place imaginable. The Sun would be a dim point behind you. Proxima Centauri would be a dim point ahead of you. And in every other direction, there would be nothing but cold, silent, empty space. You would be farther from anything solid than your mind can truly comprehend. Now, zoom out a little more. Our Sun and Proxima Centauri are part of what astronomers call the local stellar neighborhood. This is a region of space about 30 light years across, containing a few dozen stars. Some of these stars are small red dwarfs, dim and cool. Some are stars like our Sun, medium-sized and yellow. A few are larger, hotter and brighter. These stars are our closest neighbors in the galaxy. They drift through space together, slowly orbiting the center of the Milky Way. But even in this neighborhood, the stars are incredibly far apart. If you shrank the Sun down to the size of a grain of sand, Proxima Centauri would be another grain of sand 4 miles away, and there would be nothing in between. No planets, no dust, just 4 miles of empty space. Our Sun is not special. It is not the biggest or the brightest. It is not the hottest or the coolest. It is in almost every way average. There are trillions of stars in the universe, and most of them are just like ours. The Sun is a middle-aged star, about halfway through its life. It has been burning for about 4.6 billion years, and it will keep burning for another 5 billion years. Then it will swell up into a red giant, swallow the inner planets, and eventually shrink down into a white dwarf, a tiny, fading ember. That is the fate of stars like ours. But other stars have different stories. Some stars are much bigger than the Sun. These massive stars burn hotter and brighter, but they live much shorter lives. They might only last a few million years before they explode in a supernova, one of the most violent events in the universe. Other stars are much smaller than the Sun. These red dwarfs burn slowly and coolly, and they can last for trillions of years. Some red dwarfs that formed when the universe was young are still burning today, and they will keep burning long after our Sun has died. Now, let us zoom out even more. Our local stellar neighborhood is just one tiny corner of a much larger structure called the Orion Arm. The Orion Arm is a spiral arm of the Milky Way galaxy. Picture a giant pinwheel spinning slowly in space. The Milky Way has several of these spiral arms, curving out from the center like the arms of a whirlpool. Our Sun sits about halfway out along one of these arms. We are not in the center of the galaxy. We are not on the edge either. We are somewhere in the suburbs, a quiet region where not much exciting happens. And that is probably a good thing. The center of the galaxy is crowded and chaotic, full of densely packed stars and intense radiation. life would struggle to survive there. Out here in the Orion Arm, things are calm and stable. There is enough distance between stars that planets can form and life can evolve without being blasted by nearby supernovas or swallowed by black holes. The Milky Way galaxy is home to somewhere between 200 and 400 billion stars. Let that number sit with you for a moment. 200 billion stars. Maybe 400 billion. No one knows the exact number because we cannot see the whole galaxy from where we are. We are inside it, like trying to count all the trees in a forest while standing in the middle of the forest. But we can make estimates based on what we observe, and those estimates tell us that our galaxy is almost unimaginably large. The Milky Way is about 100,000 light-years across. If you tried to travel from one side of the galaxy to the other at the speed of light, it would take you 100,000 years. And remember, nothing can move faster than light. So there is no shortcut. There is no way to speed it up. That is just how big the galaxy is. From our position in the Orion Arm, the center of the galaxy is about 26,000 light-years away. On a clear night, if you are far from city lights, you can look up and see a faint band of light stretching across the sky. That is the Milky Way. You are looking at the combined glow of billions of distant stars, all packed together in the spiral arms and the galactic core. It is beautiful. It is humbling. And it is just a tiny fraction of what is actually out there. At the very center of the Milky Way, hidden behind thick clouds of dust and gas, lies a supermassive black hole. This black hole is called Sagittarius A star, and it weighs about 4 million times more than our Sun. It sits at the gravitational heart of the galaxy, holding everything together. All those billions of stars, including our Sun, are slowly orbiting around it. Our Sun takes about 230 million years to complete one orbit around the galactic center. The last time our Sun was in this part of the galaxy, dinosaurs were just starting to appear on Earth. The next time we come back around, who knows what Earth will look like, or if humans will still be here. But here is the thing. The Milky Way is not alone. When you look up at the night sky, most of the stars you see are part of our galaxy. But if you look carefully, you can also see a few faint fuzzy patches of light. Those patches are other galaxies, entire galaxies, each one containing billions or even trillions of stars. And they are so far away that their light has been traveling through space for millions of years before it reaches your eyes. The closest large galaxy to the Milky Way is called Andromeda. Andromeda is about 2.5 million light-years away. That means the light you see from Andromeda tonight left that galaxy 2.5 million years ago, long before humans existed. When that light started its journey, our ancestors were still small, ape-like creatures living in Africa. Andromeda is bigger than the Milky Way. It contains about 1 trillion stars. 1 trillion. If you tried to count to 1 trillion, counting one number every second, it would take you 31,000 years. Andromeda is so massive that you can see it with the naked eye on a dark night. It looks like a faint glowing cloud. But through a telescope, you can make out its spiral shape, its bright core, and its sweeping arms of stars. Andromeda is moving toward us. In fact, the Milky Way and Andromeda are on a collision course. In about 4.5 billion years, the two galaxies will crash into each other. But do not worry. When galaxies collide, the stars are so far apart that they almost never actually hit each other. Instead, the galaxies pass through each other like two clouds of smoke, and their gravity pulls them into strange, new shapes. Eventually, the Milky Way and Andromeda will merge into one giant galaxy. By then, the Sun will be near the end of its life, and Earth will probably be long gone. But the stars themselves will continue on, rearranged into a new cosmic structure. The Milky Way and Andromeda are not alone. They are part of a small cluster of galaxies called the Local Group. The Local Group contains about 54 galaxies, though most of them are tiny dwarf galaxies, much smaller than the Milky Way or Andromeda. These dwarf galaxies orbit around the two larger galaxies like moons orbiting a planet. The Local Group is about 10 million light-years across. That is 100 times bigger than the Milky Way. Let that sink in. The Milky Way, with its hundreds of billions of stars, is just one small part of a much larger neighborhood, and the space between galaxies in the Local Group is almost completely empty. There are no stars out there, no planets, no light, just vast, dark, silent voids. But the Local Group is not the end. Zoom out even more, and you will see that the Local Group is just a tiny piece of an even larger structure called the Virgo supercluster. The Virgo supercluster contains about 100 galaxy groups and clusters, with a total of around 47,000 galaxies. 47,000 galaxies, each one containing billions or trillions of stars, each star potentially surrounded by planets. The Virgo supercluster is about 110 million light-years across. From this distance, galaxies start to look like tiny dots. The Milky Way, which seemed so enormous just a moment ago, is now barely visible. It is just one faint speck in a vast web of galaxies, all held together by gravity. The Virgo supercluster is shaped like a flat disk, with most of the galaxies concentrated in the middle. At the heart of the supercluster lies the Virgo cluster, a dense collection of about 1 to 300 galaxies. The gravity from the Virgo cluster is so strong that it pulls on all the other galaxies around it, including our Local Group. We are slowly drifting toward the Virgo cluster, falling into its gravitational well. But this motion is incredibly slow. It will take billions of years for us to get there, and by then, the universe will look very different. Now, here is where things get even stranger. The Virgo supercluster is not the biggest structure in the universe. It is just one small part of an even larger structure called the Laniakea supercluster. Laniakea is a Hawaiian word that means immeasurable heaven, and it is a fitting name. Laniakea contains about 100,000 galaxies, including the Milky Way, Andromeda, and the entire Virgo supercluster. It is about 520 million light-years across. Imagine trying to comprehend that distance. Light, traveling at 186,000 miles per second, would take 520 million years to cross from one side of Laniakea to the other. Our Sun has not even existed for that long. The Sun formed about 4.6 billion years ago, but it will only live for about 10 billion years total. So in the time it takes light to cross Laniakea, entire generations of stars will be born, live, and die. Laniakea is not just a random collection of galaxies. It is a supercluster, which means all the galaxies inside it are connected by gravity and moving together through space. Scientists discovered Laniakea by mapping the motion of galaxies. They found that all the galaxies in this region are flowing toward a single point, like water swirling down a drain. That point is called the Great Attractor. The Great Attractor is a gravitational anomaly, a region of space with so much mass that it pulls everything nearby toward it. No one knows exactly what the Great Attractor is. It might be a massive cluster of galaxies, or it might be something even bigger. But whatever it is powerful enough to pull the entire Laniakea supercluster toward it. Our galaxy, our Local Group, our Virgo supercluster, everything is drifting slowly in that direction. We are part of a cosmic river, flowing through space toward a destination we cannot see. But even Laniakea is just one small part of the universe. If you zoom out far enough, you start to see the true structure of the cosmos. Galaxies and superclusters are not scattered randomly through space. Instead, they form a pattern. They cluster together along giant filaments, like beads on a string. These filaments stretch for hundreds of millions of light years, connecting superclusters to each other. And between the filaments, there are voids, enormous, empty voids, where almost no galaxies exist. These voids are the largest empty spaces in the universe. Some of them are more than 1 billion light years across. If you were floating in the middle of one of these voids, you would be surrounded by darkness. The nearest galaxy might be hundreds of millions of light years away, so far that even with the most powerful telescope, you would barely be able to see it. These voids are almost completely empty. There are no stars, no planets, no gas, no dust, just space itself, stretching on forever. This structure, with filaments and voids, is called the cosmic web. From a distance, it looks like a giant three-dimensional spiderweb, with glowing threads of galaxies connected by invisible strands of gravity. The cosmic web is the largest structure in the universe. It is the skeleton of the cosmos, the framework that holds everything together. And it is shaped by forces we are only beginning to understand. One of those forces is dark matter. Dark matter is a mysterious substance that makes up about 27% of the universe. We cannot see it. It does not emit light or heat. It does not interact with regular matter in any way we can detect. But we know it is there because we can see its gravity at work. Dark matter holds galaxies together. Without it, galaxies would fly apart. The stars are moving too fast, and there is not enough visible matter to keep them bound together by gravity. So there must be something else, something invisible, providing the extra gravitational pull. That something is dark matter. Scientists do not know what dark matter is made of. It might be exotic particles that do not interact with light. It might be tiny black holes, or it might be something else entirely, something we have not even thought of yet. The other major force shaping the universe is dark energy. Dark energy makes up about 68% of the universe. It is even stranger than dark matter. While dark matter pulls things together with gravity, dark energy pushes things apart. It is causing the universe to expand, and not just expand, but accelerate. The farther away a galaxy is, the faster it is moving away from us. Galaxies that are billions of light years away are racing away from us at speeds close to the speed of light, and the space between us and them is stretching, creating more and more distance. This is not because the galaxies are moving through space. It is because space itself is expanding. Imagine drawing dots on a balloon and then inflating the balloon. As the balloon expands, the dots move farther apart, but they are not actually moving across the surface. The surface itself is stretching. That is what is happening with the universe. Space itself is growing, and everything inside it is being carried along for the ride. Because of dark energy, the universe is expanding faster and faster. And because of this expansion, there is a limit to how much of the universe we can see. We call this limit the observable universe. The observable universe is everything that we can possibly see from Earth. Everything whose light has had time to reach us since the Big Bang. The Big Bang happened about 13.8 billion years ago. That was the moment when the universe began, when all of space, time, matter, and energy exploded into existence from a single, infinitely dense point. Since then, the universe has been expanding and cooling, and light from distant objects has been traveling through space, trying to reach us. But because the universe is expanding, and because space itself is stretching, some objects are so far away that their light will never reach us. They are moving away faster than their light can travel toward us. These objects are beyond the edge of the observable universe. The observable universe is about 93 billion light-years across. This is bigger than you might expect. After all, if the universe is only 13.8 billion years old, should not the observable universe only be 13.8 billion light-years across? The answer is no, because space has been expanding the whole time. While light was traveling toward us, space was stretching, making the distance even greater. So the farthest objects we can see are now about 46.5 billion light-years away in every direction. That gives us a total diameter of 93 billion light-years for the observable universe. But here is the strange part. The observable universe is not the whole universe. It is just the part we can see. The actual universe might be much, much bigger. It might even be infinite. We do not know. We cannot know, because there is no way to see beyond the observable universe. The light from those distant regions has not had time to reach us yet, and because of the expansion of space, it never will. Inside the observable universe, there are about 2 trillion galaxies. 2 trillion. Each one with billions or trillions of stars, each star potentially surrounded by planets. The numbers are so staggering that they lose all meaning. You cannot picture 2 trillion galaxies. You cannot imagine how much space they take up, or how many stars they contain, or how many worlds might exist. It is beyond human comprehension. And yet, even with all those galaxies, the universe is still mostly empty. Most of space is just that. Space. Vast, dark, silent emptiness. If you removed all the stars and galaxies and just left the empty space, you would barely notice the difference. The universe is so big, and matter is so spread out, that even 2 trillion galaxies barely make a dent. So let us return to the question we started with. How small is Earth really? We have traveled from the surface of our planet, up through the atmosphere, past the moon, past the other planets, through the solar system, across the Oort cloud, between the stars, through the Milky Way, past Andromeda, through the local group, across the Virgo supercluster, into Laniakea, and finally to the edge of the observable universe. At every step, Earth became smaller. First, it was just one planet among 8. Then it was one world in a solar system dominated by the sun. Then it was a tiny speck in a galaxy of hundreds of billions of stars. Then it was a barely visible dot in a supercluster of tens of thousands of galaxies. And finally, it became invisible, lost in a universe containing 2 trillion galaxies spread across 93 billion light-years of space. Earth is so small that if you tried to show it on a map of the observable universe, you could not. There would not be a pixel small enough. Even the sun would not show up. Even the Milky Way would barely be visible. Earth is less than a speck of dust. It is less than a grain of sand. It is less than an atom. In the grand scheme of the universe, Earth is so close to nothing that it might as well not exist. Everything you know, everyone who has ever lived, every civilization, every war, every achievement, every failure, all of it happened on this one tiny, fragile world, floating in an incomprehensibly vast ocean of space. All of human history, from the first Stone Age tools to modern skyscrapers and spacecraft, happened on a world so small that the universe would not even notice if it disappeared. And yet, here is the beautiful part. Despite being so unimaginably small, Earth is also incredibly special. As far as we know, Earth is the only place in the universe where life exists. We have searched the skies and sent probes to other planets. We have listened for signals from distant stars. And so far, we have found nothing. No other worlds teeming with life. No alien civilizations sending messages across the cosmos. Just silence. That does not mean we are alone. The universe is so vast, and there are so many stars and planets that it seems almost impossible for Earth to be the only place with life. Somewhere out there, on some distant world orbiting a distant star, there might be oceans filled with strange creatures, or forests of alien plants, or even beings looking up at their own night sky and wondering if they are alone. But we have not found them yet. And until we do, Earth is the only place we know of where the universe has become aware of itself. Think about that for a moment. You are made of atoms. Those atoms were forged inside stars billions of years ago. When those stars exploded in supernovas, they scattered those atoms across space. Over time, those atoms came together to form clouds of gas and dust. Those clouds collapsed under their own gravity, creating new stars and planets. One of those planets was Earth. And on Earth, those atoms organized themselves into molecules, and molecules into cells, and cells into living things. And eventually, after billions of years of evolution, those atoms became you. You are made of stardust, literally. The carbon in your body, the oxygen you breathe, the iron in your blood, all of it was created in the heart of a dying star. You are the universe looking at itself. You are a small part of the cosmos that has gained the ability to think and feel and wonder. And that makes Earth special. Not because it is big, not because it is powerful, not because it dominates the universe, but because it is a place where the universe has become conscious. On this tiny, fragile world, life has emerged, and intelligence has evolved, and beings have arisen who can look up at the stars and ask questions. Who are we? Where did we come from? What is our place in the universe? These questions matter. They matter because asking them means we care. It means we are not content to simply exist. We want to understand. We want to know. And in a universe that is vast and cold and indifferent, that desire to understand is something remarkable. So yes, Earth is unimaginably small. When you compare it to the solar system, or the galaxy, or the universe, it is almost nothing. But it is also home. It is the only home we have. And for now, it is the only place in the cosmos where we know for certain that life exists. That makes it worth protecting, worth cherishing, worth marveling at. Because even though Earth is a pale blue dot, invisible on the cosmic scale, it is our pale blue dot. And everything we care about is here. When you look up at the night sky and see those distant stars, remember that each one might have its own planets. Some of those planets might be like Earth. Some might even have life. But none of them are home. None of them have oceans filled with whales and dolphins, or forests filled with birds and insects, or cities filled with billions of humans living and loving and dreaming. Those things exist here, only here, on this one small world, lost in the immensity of space. There is something humbling about understanding your place in the universe. It puts things in perspective. The problems that feel so huge, the worries that keep you up at night, they are still important. They still matter, but they are also temporary. They are happening on one tiny world, in one brief moment of cosmic time. The universe is 13.8 billion years old. Humans have only existed for about 300,000 years. That is less than a blink of an eye in cosmic terms. And in another few billion years, the sun will expand into a red giant and swallow the earth. Everything we have built, everything we have achieved, will be gone. The pyramids, the great cities, the works of art and music and literature, all of it will be erased. The earth itself will be consumed, and the universe will continue on, uncaring and unchanged. That might sound depressing, but it does not have to be, because it also means that what we do right now matters. This moment, this brief flash of time when humans exist and Earth is habitable, is all we have. And we can choose to make it meaningful. We can choose to treat each other with kindness. We can choose to protect the planet that gave us life. We can choose to look up at the stars and wonder and explore and dream. We can choose to ask questions, to seek answers, to push the boundaries of what we know. We can choose to create beauty, to tell stories, to build things that last, even if they will not last forever. Because the fact that everything is temporary does not make it meaningless. It makes it precious. A flower does not last forever, but that does not make it any less beautiful. A song eventually ends, but that does not mean it is not worth listening to. And a life eventually ends, but that does not mean it is not worth living. The same is true for Earth and for humanity and for all the things we care about. When you understand how small Earth is, you also understand how rare it might be. We do not know if there are other planets like ours out there. We do not know if life is common or if we are alone. But we do know that Earth is special to us. It is the only place where we can live, the only place where we have ever lived, and the only place we can call home. That makes it worth protecting. Not because it is the center of the universe, because it is not. Not because it is the biggest or the most important, because it is not. But because it is ours, and because for now, it is all we have. The universe is vast and beautiful and full of wonders, but none of those wonders mean anything if we are not here to witness them. So the next time you look up at the night sky, take a moment to think about where you are. You are standing on a small planet, orbiting an average star, in the outer arm of a spiral galaxy, which is part of a small cluster of galaxies, which is part of a supercluster, which is part of a cosmic web, which is part of an observable universe that is 93 billion light years across. You are part of something unimaginably vast, and yet you are also part of something small and fragile and precious. You are part of life on Earth, and as far as we know, that is the rarest thing in the universe. So take care of it, marvel at it, be grateful for it, because even though Earth is a tiny speck in the cosmos, it is also the most important place in your world. It is home. And maybe, one day, we will venture out into that vast universe. Maybe we will build ships that can travel between the stars. Maybe we will find other worlds, other forms of life, other civilizations that have also looked up at their skies and wondered if they were alone. Maybe we will spread out across the galaxy and then across the universe, carrying the light of Earth with us into the darkness. Or maybe we will stay here, on this one small world, living our lives and telling our stories and gazing up at the stars, content to wonder. Either way, we will still be part of the universe. We will still be made of stardust, and we will still be part of the incredible, ongoing story of the cosmos. The atoms in your body were forged in the heart of ancient stars. Those stars lived for millions or billions of years, burning bright in the darkness before finally exhausting their fuel and exploding. When they exploded, they released everything they had created, all the heavy elements like carbon and oxygen and iron, out into space. Those elements drifted through the galaxy for eons, slowly coming together into new clouds of gas and dust. And eventually, one of those clouds collapsed and formed our sun and the planets and Earth. And here you are. A collection of atoms that have journeyed across billions of years and trillions of miles, just to be here, just to be you. You are not separate from the universe. You are part of it. You are a small piece of the cosmos that has come alive, that has opened its eyes and looked around and said, I am here. I exist. And that is extraordinary. Think about all the unlikely events that had to happen for you to exist. The universe had to begin. Stars had to form and explode. The solar system had to coalesce from a cloud of gas and dust. Earth had to form at just the right distance from the sun, not too hot and not too cold. Water had to cover most of the surface. An atmosphere had to develop. Life had to emerge from the primordial oceans. Simple cells had to evolve into complex organisms. Fish had to crawl onto land. Dinosaurs had to live and die. Mammals had to survive and thrive. Humans had to evolve. Your ancestors had to survive countless dangers, wars, famines, plagues. And finally, your parents had to meet and have you. Every single one of those events was necessary for you to be here right now, reading these words, thinking these thoughts. If any one of them had gone differently, you would not exist. And yet, here you are, against all odds. That makes you a miracle. Not because you are special in some cosmic sense, but because you are improbable. You are a roll of the dice that came up in your favor, and so is everyone else. Every person you have ever met, every stranger you have passed on the street, they are all miracles too. They are all collections of stardust that have somehow come together just for a brief moment to live and breathe and think. And that is beautiful, but it is also fragile. Life on Earth has faced extinctions before. Asteroid impacts, volcanic eruptions, ice ages, all of these have wiped out countless species. About 66 million years ago, an asteroid struck the Earth and killed off the dinosaurs. If that asteroid had missed, dinosaurs might still rule the planet, and mammals might never have evolved into humans. We exist because of a cosmic accident, and another cosmic accident could wipe us out just as easily. That is why it is so important to take care of the planet we have. We cannot move to another world, not yet. We do not have the technology to terraform Mars or travel to distant star systems. Earth is our only home, and if we ruin it, if we poison the oceans and burn the forests and fill the atmosphere with pollutants, we will have nowhere else to go. The universe will not care. It will keep spinning, keep expanding, keep creating new stars and galaxies, but we will be gone. And all the things we created, all the art and music and stories, all the love and laughter and joy, all of it will disappear. That would be a tragedy, not because it matters to the universe, but because it matters to us. Understanding the scale of the universe can make you feel insignificant, and in some ways, you are. The universe is so vast, and you are so small, that your existence barely registers on the cosmic scale. But that does not mean you do not matter. You matter to the people around you. You matter to your family, your friends, the people who love you. You matter to yourself. And that is enough. You do not need to matter to the universe. You just need to matter to someone. And you do. Every act of kindness, every moment of joy, every time you make someone smile or help them through a hard time, that matters. It might not change the course of the cosmos, but it changes the course of their life, and that is what matters. Life is not about being important on a cosmic scale. It is about being important to the people you care about, and the people who care about you. It is about living your life in a way that feels meaningful to you. And that can happen on a tiny planet, in a tiny solar system, in a tiny galaxy, in a vast universe. So do not let the size of the universe make you feel small. Let it make you feel grateful. Grateful that you exist at all. Grateful that you get to be part of this incredible, strange, beautiful cosmos. Grateful that you get to look up at the stars and wonder, because not everyone gets that chance. Most of the matter in the universe is just hydrogen and helium, drifting through space, cold and lifeless. But you are alive, you are conscious, you are aware. And that makes you one of the rarest things in the universe. So take a deep breath, look around, appreciate where you are, because you are standing on a small planet, orbiting an average star, in a vast and ancient universe. And even though you are small, you are also part of something much bigger. You are part of the story of the cosmos. And that is something worth celebrating. If you enjoyed this journey through the universe, if it made you think, or feel, or see the world a little differently, then please come back and join us again. Here on Cosmic Drift, we take these kinds of journeys often, exploring the wonders of space and time, and the incredible beauty of the cosmos. Thank you for being here. Thank you for taking the time to look up at the stars with us. And remember, no matter how small you feel, you are made of stardust. You are part of the universe, and that makes you extraordinary. Let us think more deeply about what distance really means when we talk about space. When you drive to a nearby city, maybe 50 miles away, that distance feels real. You can picture it. You have probably driven that far before. You know how long it takes. You can see the road ahead of you, watch the mile markers tick by, and eventually arrive at your destination. Distance, in that context, makes sense. But space does not work that way. The distances in space are so enormous that they stop feeling real. Your brain cannot process them. They become just numbers, just abstract concepts. And yet, those distances are real. They exist, and they shape everything about how the universe works. Let us start with the Moon. The Moon is Earth's only natural satellite, a grey ball of rock about 1/4 the size of Earth. It orbits us at an average distance of about 238,900 miles. That is close enough that we have sent people there. Between 1969 and 1972, 12 astronauts walked on the lunar surface. They traveled for about 3 days to get there, orbiting Earth, firing rockets to break free of Earth's gravity, coasting through empty space, and then firing rockets again to slow down and enter lunar orbit. It was one of the greatest achievements in human history. And yet, the Moon is right next door in cosmic terms. If you could drive to the Moon at highway speeds, going 60 miles per hour without ever stopping, it would take you about 166 days to get there. That is more than 5 months of non-stop driving. And that is just to reach our nearest neighbor in space. Now think about Mars. Mars is the planet that many people dream of visiting someday. It is the most Earth-like planet in the solar system. It has polar ice caps, seasons, mountains, and canyons. NASA has sent rovers to explore its surface, and there are plans to send humans there within the next few decades. But Mars is much farther away than the Moon. At its closest approach to Earth, Mars is about 34 million miles away. At its farthest, it is about 250 million miles away. This distance changes because both Earth and Mars are orbiting the Sun, and their orbits bring them closer together and farther apart over time. When scientists plan a mission to Mars, they have to wait for the right moment, when the two planets are aligned just right. Even then, It takes about 7 months for a spacecraft to travel from Earth to Mars. 7 months in a cramped metal capsule, hurtling through the void, with no way to turn back. And that is assuming everything goes perfectly. If something breaks, if there is a medical emergency, there is no help coming. You are on your own. That is the reality of space travel. The distances are so great that even our closest planetary neighbors feel impossibly far away. Now let us talk about the Sun. The Sun is much, much farther away than Mars. We orbit the Sun at a distance of about 93 million miles. This distance is so useful for measuring things in our solar system that astronomers gave it a special name, the astronomical unit. 1 AU equals 93 million miles. It is a convenient way to describe distances without having to write out huge numbers every time. For example, Mars orbits at about 1.5 AU from the Sun. Jupiter orbits at about 5.2 AU. Saturn is at 9.5 AU. Neptune, the farthest planet, is at 30 AU. These numbers are easier to work with than saying Neptune is 2.8 billion miles from the Sun. But here is the thing. Even 1 AU is an almost incomprehensible distance. Light, which is the fastest thing in the universe, takes 8 minutes and 20 seconds to travel from the Sun to Earth. That means if you could somehow hitch a ride on a beam of sunlight, you would spend more than 8 minutes traveling through empty space before you reached Earth. And here is something strange to think about. When you look up at the Sun, you are not seeing it as it is right now. You are seeing it as it was 8 minutes ago. The light you are looking at left the Sun 8 minutes in the past, traveled across 93 million miles of space, and finally reached your eyes. In a sense, you are looking back in time. This is true for everything you see in space. When you look at the stars at night, you are not seeing them as they are now. You are seeing them as they were years, decades, or even centuries ago. Some of the stars you see might not even exist anymore. They might have exploded or faded away, but their light is still traveling through space, and it will not reach us for many more years. The farther away something is, the farther back in time you are looking. This is one of the strange consequences of the speed of light. Light is fast, but space is so vast that even light takes time to cross it. And that means when we look out into the universe, we are also looking into the past. Now, think about traveling to the outer planets. Jupiter, the giant of our solar system, orbits at about 5.2 AU from the Sun. That is 484 million miles. Light from the Sun takes about 43 minutes to reach Jupiter. If you were standing on one of Jupiter's moons, looking up at the Sun, you would be seeing it as it was 43 minutes ago. And if you wanted to travel to Jupiter in a spacecraft, it would take years. The fastest spacecraft ever built, NASA's New Horizons probe, took about 13 months to reach Jupiter. And that was just a flyby. It did not stop. It did not orbit. It just flew past, taking pictures and gathering data, and then continued on into the outer solar system. A mission that wanted to orbit Jupiter and send back detailed information would take much longer. And if you wanted to send humans to Jupiter, the journey would be even more difficult. You would need enough food, water, and oxygen for the crew to survive several years in space. You would need shielding to protect them from radiation. You would need systems to keep the spacecraft functioning for the entire journey. And even then, there is no guarantee that everything would work. Space is unforgiving. One small mistake, one equipment failure, and the mission could be over. Saturn is even farther. It orbits at 9.5 AU from the Sun, about 886 million miles away. Light from the Sun takes about 80 minutes to reach Saturn. The Cassini spacecraft, which orbited Saturn and studied its rings and moons, took about 7 years to get there. 7 years of traveling through empty space. Think about that. 7 years is a significant portion of a human life. By the time the spacecraft arrived, the scientists who designed the mission were older. Some of them had retired. Some had passed away. And yet, the mission continued. Cassini spent 13 years orbiting Saturn, sending back thousands of images and vast amounts of data, before finally plunging into Saturn's atmosphere and burning up in 2017. It was one of the most successful space missions in history, but it also showed just how difficult it is to explore the outer solar system. These places are so far away that even getting there is a monumental achievement. And then there is Neptune, the farthest true planet from the Sun. Neptune orbits at 30 AU, about 2.8 billion miles away. Light from the Sun takes more than 4 hours to reach Neptune. Only one spacecraft has ever visited Neptune, Voyager 2. It flew past Neptune in 1989, taking the first close-up images of the planet and its moons. The journey took 12 years. 12 years of traveling through space. By the time Voyager 2 reached Neptune, the technology on Earth had advanced so much that the spacecraft was almost obsolete. But it still worked, and it still sent back data, and it gave us our only close-up look at this distant, icy world. After flying past Neptune, Voyager 2 continued on, leaving the solar system behind and heading out into interstellar space. It is still out there, more than 40 years after it was launched, still sending back faint signals from the edge of the solar system. But the solar system does not end at Neptune. In fact, Neptune is just the beginning of the outer solar system. Beyond Neptune lies the Kuiper Belt, a vast region of icy objects left over from when the solar system formed. The Kuiper Belt starts at about 30 AU and extends out to about 50 AU. It is home to Pluto, which was once considered the 9th planet, but is now classified as a dwarf planet. Pluto is small, only about 2/3 the size of Earth's moon. It has a thin atmosphere that freezes and falls to the surface as snow when Pluto moves farther from the Sun. In 2015, NASA's New Horizons spacecraft flew past Pluto, giving us our first close-up views of this distant world. The journey took 9.5 years. By the time New Horizons reached Pluto, the scientists who had originally proposed the mission were nearing retirement, but the images it sent back were worth the wait. Pluto turned out to be far more interesting than anyone expected, with towering mountains made of ice, vast plains of frozen nitrogen, and a thin blue haze in its atmosphere. The Kuiper Belt is full of objects like Pluto. Thousands of icy worlds, most of them much smaller than Pluto, orbit the Sun in this distant region. Some of these objects are round like small planets. Others are irregularly shaped, more like asteroids. They are all incredibly cold. The Sun is so far away that it provides almost no heat. Temperatures in the Kuiper Belt hover around -400 degrees Fahrenheit. That is cold enough to freeze almost any substance. Even gases like nitrogen and methane, which are usually in the atmosphere on Earth, freeze solid in the Kuiper Belt. These icy worlds are like time capsules. They have been frozen since the solar system formed, and studying them helps scientists understand what the early solar system was like, back when the planets were first coming together. But the Kuiper Belt is not the edge of the solar system, not even close. Beyond the Kuiper Belt, even farther out, lies the Oort cloud. The Oort cloud is a theoretical shell of icy debris that surrounds the entire solar system. It is so far away that no spacecraft has ever reached it. In fact, no spacecraft will reach it for thousands of years. The Oort cloud is thought to start at about 2000 AU from the Sun and extend out to maybe 100,000 AU. Let me put that in perspective. If the Sun is a basketball sitting in the middle of a city, the Kuiper belt would be about a mile away. The Oort cloud would stretch out more than 50 miles in every direction. It is enormous, and it is almost entirely empty. Scientists believe the Oort cloud contains trillions of icy objects, but they are spread out over such a vast area that the average distance between them is millions of miles. If you were somehow standing in the Oort cloud, you would not see anything around you, just darkness. The Sun would be a bright star in the sky, no bigger or brighter than any other star. You would be utterly alone. The Oort cloud is the source of long-period comets, those icy visitors that occasionally swing through the inner solar system and put on a spectacular show. Every few years, a comet from the Oort cloud gets nudged by the gravity of a passing star or by the gravitational tug of the galaxy itself, and it starts falling toward the Sun. It takes thousands or even millions of years for the comet to make the journey, but eventually it enters the inner solar system, where the Sun's heat causes the ice to vaporize, creating a glowing tail that can stretch for millions of miles. These comets are messengers from the very edge of the solar system, bringing us samples of ice and rock that have been frozen since the solar system formed. When we study comets, we are looking at material that is more than 4.5 billion years old. So the solar system is vast. It is not just the 8 planets orbiting the Sun. It is the Kuiper belt, the Oort cloud, the asteroids, the comets, the moons, and all the empty space in between. And all of this, everything from the Sun to the farthest edge of the Oort cloud, is held together by the Sun's gravity. The Sun is so massive that its gravitational pull reaches out across trillions of miles, keeping everything in orbit. But even the Sun's gravity has limits. At the very edge of the Oort cloud, the Sun's gravity is so weak that it barely holds onto the icy objects there. A slight nudge from a passing star is enough to knock them loose, sending them tumbling out into interstellar space. Interstellar space, that is the space between the stars, and it is unimaginably vast. To understand just how vast, let us talk about the nearest star to the Sun. That star is called Proxima Centauri, and it is part of a triple star system called Alpha Centauri. Proxima Centauri is a small red dwarf star, much cooler and dimmer than our Sun. It is about 4.24 light-years away. Now, a light-year is a unit of distance, not time. It is the distance that light travels in 1 year. Light moves at about 186,000 miles per second. In 1 year, light travels about 5.88 trillion miles. So Proxima Centauri is about 25 trillion miles away. That is such a huge number that it barely means anything to the human brain. You cannot picture 25 trillion miles. But here is a way to think about it. If you left Earth right now in the fastest spacecraft ever built, traveling at about 36,000 miles per hour, it would take you about 80,000 years to reach Proxima Centauri. 80,000 years. That is more than 10 times longer than all of recorded human history. And Proxima Centauri is the closest star. The next closest star, Barnard's star, is about 6 light-years away. The next one after that is a bit farther, and so on. The stars in our galaxy are scattered across vast distances, separated by gulfs of empty space that are almost impossible to comprehend. If you were somehow floating halfway between the Sun and Proxima Centauri, you would be 2 light-years from the nearest star in any direction. That is about 12 trillion miles. There would would be nothing around you, no planets, no asteroids, no comets, just cold, dark, empty space. The sun would be a faint point of light behind you. Proxima Centauri would be a faint point of light ahead of you. And in every other direction, you would see distant stars so far away that they look like tiny pinpricks. This is what interstellar space is like. Lonely, empty, silent. But even though interstellar space is mostly empty, it is not completely empty. There are thin clouds of gas and dust drifting between the stars. These clouds are incredibly thin, far thinner than any vacuum we can create on Earth. In some regions, there might be only 1 atom per cubic centimeter. That is almost nothing. For comparison, the air you are breathing right now contains about 10 quintillion atoms per cubic centimeter. So interstellar space is unimaginably empty. And yet, these thin clouds of gas and dust are important. They are the raw material for new stars. Over millions of years, gravity pulls the gas and dust together, compressing it, heating it, until finally it becomes dense enough and hot enough for nuclear fusion to begin. And when that happens, a new star is born. This is how the Sun formed, about 4.6 billion years ago. It started as a cloud of gas and dust, left over from previous generations of stars. That cloud collapsed under its own gravity, and as it collapsed, it started to spin. The spinning caused it to flatten into a disk, with most of the mass concentrated in the center. The center became hotter and hotter, until finally, the temperature and pressure were high enough for hydrogen atoms to start fusing into helium. That fusion released enormous amounts of energy, and the sun began to shine. Meanwhile, the leftover material in the disk clumped together to form the planets. The inner planets, like Earth, formed from rock and metal. The outer planets, like Jupiter and Saturn, formed from gas and ice. And here we are, 4.6 billion years later, living on one of those planets, looking up at the star that gave us life. Every star you see in the night sky formed in a similar way. Some stars are bigger than the sun, some are smaller, some are hotter, some are cooler. But they all formed from clouds of gas and dust, and they all shine because of nuclear fusion happening in their cores. Stars are the engines of the universe. They take simple elements like hydrogen and helium and fuse them into heavier elements like carbon, oxygen, and iron. When a star reaches the end of its life, it either gently puffs off its outer layers, creating a beautiful cloud called a planetary nebula, or it explodes in a supernova, one of the most violent events in the universe. Either way, the star releases the elements it created back into space, and those elements become part of new clouds of gas and dust, which eventually form new stars and new planets. This is the cycle of stellar life. Stars are born, they live for millions or billions of years, and then they die, enriching the galaxy with the elements they created. We are part of that cycle. The atoms in your body were created inside stars. You are literally made of stardust. Our sun is just one star among hundreds of billions in the Milky Way galaxy. The Milky Way is a spiral galaxy, which means it has a flat, disc-like shape with spiral arms curving out from the center. If you could look at the Milky Way from above, it would look like a giant pinwheel, slowly rotating. Our sun is located about halfway out from the center, in one of the spiral arms called the Orion Arm. The Milky Way is about 100,000 light-years across. That means if you tried to travel from one side of the galaxy to the other at the speed of light, it would take you 100,000 years. And remember, nothing can travel faster than light, so there is no shortcut. That is just how big the galaxy is. The Milky Way contains between 200 and 400 billion stars. The exact number is hard to pin down because we cannot see the whole galaxy from where we are. We are inside it, like trying to count all the trees in a forest while standing in the middle of the forest. But based on what we can see, and based on observations of other galaxies, scientists estimate that the Milky Way has at least 200 billion stars, and maybe as many as 400 billion. Each one of those stars is a sun, burning with nuclear fire, potentially surrounded by planets. And some of those planets might be like Earth. Some might even have life. Scientists have discovered thousands of planets orbiting other stars. These planets are called exoplanets, and they come in all shapes and sizes. Some are gas giants, even bigger than Jupiter. Some are rocky worlds, similar to Earth. Some orbit close to their stars, where temperatures are hot enough to melt metal. Others orbit far away, in the cold outer regions of their star systems. And just a few orbit in what scientists call the habitable zone. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Liquid water is essential for life as we know it. So planets in the habitable zone are the best places to look for alien life. We have found dozens of potentially habitable exoplanets so far, but we do not know if any of them actually have life. We can detect the planets by watching for the tiny dip in a star's brightness when a planet passes in front of it. But we cannot see the planets directly. They are too far away, and they are too dim compared to their stars. All we can do is study their atmospheres, looking for chemical signatures that might indicate life, like oxygen or methane. So far, we have not found any conclusive evidence, but the search continues. The center of the Milky Way is a very different place from where we live. The center is crowded and chaotic. Stars are packed much closer together there, sometimes only a few light days or light weeks apart, instead of the light years that separate stars in our neighborhood. The center also contains enormous clouds of gas and dust, where new stars are constantly being born. And at the very heart of the galaxy, hidden behind all that gas and dust, lies a supermassive black hole. This black hole is called Sagittarius A star, or Sagittarius A asterisk for short. It weighs about 4 million times more than the Sun. That might sound like a lot, but in the grand scheme of the galaxy, it is actually quite small. Other galaxies have black holes that weigh billions of times more than the Sun. Still, Sagittarius A star is massive enough to hold the entire galaxy together. All the stars in the Milky Way, including our Sun, are orbiting around it. Our Sun takes about 230 million years to complete one orbit. The last time the Sun was in this part of the galaxy, dinosaurs were just starting to walk the Earth. The next time we come around, Earth might be a very different place. Black holes are strange objects. They form when a massive star runs out of fuel and collapses under its own gravity. The collapse is so extreme that all the star's mass gets compressed into a single point, called a singularity. The gravity around a singularity is so strong that nothing can escape, not even light. That is why black holes are black. They do not emit light. They do not reflect light. They are just dark voids in space. But we know they exist because we can see their effects. We can see stars orbiting around invisible objects. We can see gas and dust swirling into black holes, heating up and emitting X-rays as it falls. And recently, scientists have even taken pictures of black holes, or rather, pictures of the glowing gas around black holes. The first image of a black hole, released in 2019, showed the black hole at the center of a galaxy called M87. It was a historic moment, the first time humans had ever directly observed one of these mysterious objects. But black holes are not just cosmic vacuum cleaners, sucking up everything around them. They actually play an important role in the formation and evolution of galaxies. The energy released by matter falling into a black hole can blow gas and dust out of the galaxy, preventing new stars from forming. This helps regulate the growth of the galaxy, keeping it from getting too big too fast. Black holes also help mix elements throughout the galaxy. When matter falls into a black hole, some of it gets ejected back out into space at high speeds, carrying heavy elements with it. Those elements then become part of new clouds of gas and dust, which eventually form new stars and planets. So in a way, black holes are not destroyers. They are recyclers, taking in old material and sending out new material, helping to shape the structure of galaxies. Now, let us zoom out even farther. The Milky Way is not alone in space. It is part of a group of galaxies called the Local Group. The Local Group contains about 54 galaxies, though most of them are small dwarf galaxies, much smaller than the Milky Way. The two largest galaxies in the Local Group are the Milky Way and the Andromeda Galaxy. Andromeda is a spiral galaxy, just like the Milky Way, but it is bigger. It contains about 1 trillion stars, compared to the Milky Way's 200 to 400 billion. Andromeda is about 2.5 million light-years away. That means the light we see from Andromeda tonight left that galaxy 2.5 million years ago, long before humans existed. Andromeda is the farthest object you can see with your naked eye. On a clear, dark night, if you know where to look, you can see it as a faint, fuzzy patch of light in the constellation Andromeda. What you are seeing is the combined glow of 1 trillion stars, all so far away that they blend together into a single smudge. It is humbling to think about. You are looking at an entire galaxy, a structure containing trillions of stars and countless planets, and it is so far away that it looks like a faint cloud. And yet, Andromeda is also on a collision course with the Milky Way. The two galaxies are moving toward each other at about 250,000 miles per hour. In about 4.5 billion years, they will collide. But do not worry. When galaxies collide, the stars are so far apart that they almost never actually hit each other. Instead, the galaxies pass through each other, and their gravitational forces pull them into strange, distorted shapes. Aberdeen, eventually, the Milky Way and Andromeda will merge into a single, giant galaxy. Astronomers have already given this future galaxy a name, Milkomeda. By the time Milkomeda forms, the Sun will be nearing the end of its life, and Earth will probably be uninhabitable. But the stars themselves will continue on, rearranged into a new configuration, orbiting a new galactic center. The Local Group is about 10 million light-years across. That is 100 times bigger than the Milky Way. And yet, on the cosmic scale, the Local Group is tiny. It is just one small cluster of galaxies in a much larger structure. Zoom out a bit more, and you will see that the Local Group is part of the Virgo supercluster. The Virgo supercluster is a massive collection of galaxy groups and clusters containing about 47,000 galaxies. At this scale, galaxies start to look like tiny dots. The Milky Way, which seemed so huge just a moment ago, is now almost invisible. It is just one speck of light among tens of thousands of other specks, all clustered together in a vast structure that stretches across 110 million light-years of space. The Virgo supercluster is shaped like a flat disk, with most of the galaxies concentrated in the middle. At the heart of the supercluster lies the Virgo cluster, a dense collection of about 1,300 galaxies. The Virgo cluster is one of the most massive structures in the nearby universe. Its gravity is so strong that it pulls on all the other galaxies around it, including our local group. We are slowly drifting toward the Virgo cluster, falling into its gravitational well. But this motion is incredibly slow. It will take tens of billions of years for us to get there, and by then, the universe will be a very different place. But the Virgo supercluster is not the whole story. In recent years, scientists have discovered that the Virgo supercluster is itself part of an even larger structure called the Laniakea supercluster. Laniakea is a Hawaiian word meaning immeasurable heaven, and it is a fitting name for such a vast structure. Laniakea contains about 100,000 galaxies, including the Milky Way, Andromeda, and the entire Virgo supercluster. It is about 520 million light-years across. To put that in perspective, light from one side of Laniakea would take 520 million years to reach the other side. That is longer than the entire history of complex life on Earth. Complex life, meaning animals and plants, has only existed for about 600 million years. So in the time it takes light to cross Laniakea, life on Earth went from simple organisms to dinosaurs to humans. Laniakea is not just a random collection of galaxies. It is a supercluster, which means all the galaxies inside it are gravitationally bound and moving together through space. Scientists discovered Laniakea by mapping the motion of thousands of galaxies. They found that all the galaxies in this region are flowing toward a single point, like water swirling down a drain. That point is called the Great Attractor. The Great Attractor is a gravitational anomaly, a region of space with so much mass that it pulls everything nearby toward it. No one knows exactly what the Great Attractor is. It might be a massive cluster of galaxies, or it might be something even bigger, like a supercluster of superclusters. But whatever it is powerful enough to pull the entire Laniakea supercluster toward it. Our galaxy, our local group, our Virgo supercluster, everything is drifting slowly in that direction, pulled by a force we cannot fully see or understand. This motion is not something you can feel. You are not being pulled toward the Great Attractor. The motion is happening on such a large scale and over such long time scales that it is imperceptible to us. But it is happening. The universe is not static. Everything is moving. Galaxies are rotating, stars are orbiting, planets are circling their stars, and on the larger scales, superclusters are flowing through space, pulled by invisible currents of gravity and dark matter. Dark matter is one of the great mysteries of modern science. We know it exists because we can see its gravitational effects. Galaxies are rotating too fast. Based on the amount of visible matter in a galaxy, stars should fly off into space, but they do not. Something is holding them together. That something is dark matter. Dark matter makes up about 27% of the universe. It does not emit light. It does not absorb light. It does not interact with regular matter in any way we can detect, except through gravity, so we cannot see it directly. We can only infer its presence by watching how it affects visible matter. Scientists have proposed many theories about what dark matter is. Some think it is made of exotic particles that do not interact with light. Others think it might be tiny black holes left over from the early universe. Still others think dark matter might not exist at all, and that our understanding of gravity is wrong. But most scientists believe dark matter is real, and that it plays a crucial role in the structure of the universe. Without dark matter, galaxies would not exist. When the universe was young, It was filled with a nearly uniform cloud of hydrogen and helium gas. Over time, gravity pulled that gas together, forming clumps. Those clumps eventually became galaxies, but there was not enough visible matter for gravity to work fast enough. The universe would have remained a smooth, boring cloud of gas. Dark matter provided the extra gravitational pull needed to form galaxies. It created a framework, a scaffolding, that visible matter could cling to. So in a sense, we owe our existence to dark matter. Without it, there would be no galaxies, no stars, no planets, and no life. But dark matter is not the only mysterious force in the universe. There is also dark energy. Dark energy is even stranger than dark matter. While dark matter pulls things together with gravity, dark energy pushes things apart. It is causing the universe to expand, and not just expand, but accelerate. The farther away a galaxy is, the faster it is moving away from us. Galaxies that are billions of light years away are racing away from us at speeds close to the speed of light, and the space between us and them is stretching, creating more and more distance. This expansion is not happening because galaxies are moving through space. It is happening because space itself is expanding. Imagine drawing dots on a balloon and then inflating the balloon. As the balloon expands, the dots move farther apart, but they are not moving across the surface of the balloon. The surface itself is stretching. That is what is happening with the universe. Space itself is growing, carrying galaxies along for the ride. Dark energy makes up about 68% of the universe. That means more than 2/3 of the universe is made of something we do not understand. We do not know what dark energy is. We do not know where it comes from. We do not know why it exists. All we know is that it is real, and it is making the universe expand faster and faster. Scientists discovered dark energy in the late 1990s when they were studying distant supernovas. They expected to find that the expansion of the universe was slowing down because gravity should be pulling everything back together. But instead, they found the opposite. The expansion was speeding up. This was a shocking discovery, and it earned the researchers a Nobel Prize. But it also left us with a profound mystery. What is dark energy? How does it work? And what will happen to the universe as it continues to expand? One possibility is that the universe will keep expanding forever. Galaxies will move farther and farther apart until eventually they are so far away that their light can no longer reach us. The night sky will become darker and darker as more and more galaxies disappear beyond the horizon. Eventually, the only galaxies we will be able to see will be the ones in our local group, and even those will merge together over time. After trillions of years, all the stars will burn out. The universe will become a cold, dark, empty place, filled with dead stars and black holes. This is called the heat death of the universe, and it is the most likely fate based on what we currently know. But there are other possibilities. Some scientists think dark energy might change over time. Maybe it will weaken, allowing the universe to stop expanding and start contracting. In that case, the universe would eventually collapse back in on itself in an event called the Big Crunch. All the galaxies, all the stars, all the matter in the universe would come rushing back together, compressed into a single, infinitely dense point, just like the one the universe started from. And maybe, after the Big Crunch, there would be another Big Bang, and the whole process would start over again. This is called the cyclic model of the universe, and it is an intriguing idea, though there is no evidence for it. Or maybe dark energy will get stronger. If that happens, the expansion of the universe will accelerate faster and faster until eventually it is expanding so fast that even atoms get torn apart. This is called the Big Rip, and it is a terrifying thought. In a Big Rip scenario, galaxies would be ripped apart first, then stars, then planets, then molecules, then atoms, and finally, even the fabric of space and time itself would be torn to shreds. The universe would end in a violent, chaotic explosion, destroying everything that exists. Fortunately, most scientists do not think the Big Rip is likely, but it is a reminder of just how much we still do not know about the universe. For now, all we can do is observe and measure. We cannot control the universe. We cannot change its fate. All we can do is try to understand it. And in trying to understand it, we learn something profound about our place in the cosmos. We are tiny. We are insignificant on the cosmic scale. But we are also part of something much larger. We are part of a universe that is 13.8 billion years old, 93 billion light years across, and filled with 2 trillion galaxies. We are part of a universe governed by laws we are still trying to figure out, shaped by forces we are still trying to understand. And that is beautiful, because it means there is always more to learn. There is always another question to ask, another mystery to solve, another discovery waiting just over the horizon. Let us talk about the structure of the universe on the larger scales. If you could somehow step outside the observable universe and look down at it, you would see something astonishing. The universe is not uniform. It is not a smooth, even distribution of galaxies. Instead, it has structure. Galaxies are not scattered randomly through space. They cluster together in groups and superclusters, and those clusters are arranged along vast filaments, like beads on a string. These filaments stretch for hundreds of millions of light years, connecting superclusters to each other. And between the filaments, there are voids, enormous, empty voids, where almost no galaxies exist. This structure is called the cosmic web, and it is the largest known structure in the universe. From a distance, it looks like a giant 3-dimensional spider web, with glowing threads of galaxies connected by invisible strands of dark matter. The cosmic web formed over billions of years, shaped by the gravitational pull of dark matter. In the early universe, matter was spread out almost uniformly, but there were tiny fluctuations, tiny differences in density. In some regions, there was slightly more matter than average. In other regions, there was slightly less. Gravity amplified these differences. Regions with more matter attracted even more matter, growing denser over time. Regions with less matter became even more empty. Over billions of years, this process created the structure we see today. Dense filaments of galaxies separated by vast empty voids. The voids are truly enormous. Some of them are more than 1 billion light years across. If you were somehow floating in the middle of one of these voids, you would be surrounded by darkness. The nearest galaxy might be hundreds of millions of light years away, so far that even with the most powerful telescope, you would barely be able to see it. You would be in the loneliest place imaginable. There would be no stars, no planets, no light. Just empty space stretching on forever in every direction. These voids are almost completely empty. There are a few stray galaxies scattered here and there, but for the most part, they contain nothing. No matter, no energy, just the fabric of space itself, expanding and stretching. And yet, even these voids are part of the universe. They are part of the structure that makes up the cosmos. They exist because of the way matter and dark matter clump together over billions of years. Without the voids, there would be no filaments. Without the filaments, there would be no clusters. And without the clusters, there would be no galaxies. The structure of the universe is interconnected. Everything affects everything else. The voids are as important as the filaments. The empty spaces are as important as the full ones. This is one of the profound lessons of cosmology. The universe is a whole, a single interconnected system. You cannot understand one part without understanding the others. Now, let us return to the question of the observable universe. We have talked about how big it is, about 93 billion light years across. But what does that actually mean? The observable universe is the part of the universe that we can see. It is everything whose light has had time to reach us since the Big Bang. But the universe itself might be much, much bigger. In fact, it might be infinite. We do not know. We cannot know. Because there is no way to see beyond the observable universe. The light from those distant regions has not had time to reach us yet, and because of the expansion of space, it never will. Those regions are forever beyond our view. This is a strange and humbling thought. There might be entire galaxies, entire superclusters, entire cosmic webs out there, beyond the edge of what we can see, and we will never know about them. They are part of the universe, but they are not part of our observable universe. They are cut off from us by the fundamental limits of physics. Light can only travel so fast, and space is expanding, so there is a limit to how far we can see. This limit is called the cosmic horizon, and it surrounds us in all directions. Beyond the cosmic horizon, the universe continues, but we will never see it. Some scientists think the universe might be infinite. If that is true, then there are an infinite number of galaxies out there, beyond our view. And if there are an infinite number of galaxies, then somewhere there might be another planet, exactly like Earth, another version of you, reading these exact words, thinking these exact thoughts. This idea is called the multiverse, and it is one of the most controversial topics in cosmology. Some scientists love it, others hate it. The problem is, there is no way to test it. We cannot see beyond the observable universe, so we cannot prove or disprove the multiverse. It remains a fascinating idea, but one that might forever be beyond the reach of science. Another strange consequence of the observable universe is that different parts of the universe have different observable universes. Imagine an alien living in a galaxy 10 billion light years away. Their observable universe would be different from ours. They would see galaxies that we cannot see, and we would see galaxies that they cannot see. Our two observable universes would overlap, but they would not be the same. And if you traveled far enough, you could reach a place where the observable universe had no overlap with ours at all. You would be looking at a completely different part of the cosmos, seeing galaxies and structures that we will never see. This is a profound reminder that the universe is bigger than any one perspective. No single observer can see it all. We each have our own limited view, our own window into the cosmos. Inside the observable universe, there are about 2 trillion galaxies. Let me say that again. 2 trillion galaxies. That number is so large it defies comprehension. If you started counting galaxies right now, counting one per second, it would take you more than 63,000 years to count them all. And each one of those galaxies contains billions or even trillions of stars. The Milky Way, with its 200 to 400 billion stars, is just one among 2 trillion. It is a drop in the ocean, a grain of sand on a beach. And Earth, our home, is just one tiny planet orbiting one average star in one typical galaxy in a universe filled with 2 trillion galaxies. When you think about it that way, the smallness of Earth becomes almost incomprehensible. And yet, Earth is also unique. As far as we know, it is the only place in the universe where life exists. We have searched the skies. We have sent probes to other planets and moons. We have listened for radio signals from distant civilizations. And so far, we have found nothing. No signs of life. No alien worlds teeming with creatures. No messages from the stars. Just silence. That does not mean we are alone. The universe is so vast, and there are so many stars and planets, that it seems almost impossible for Earth to be the only place with life. Statistically, there should be billions of planets in the habitable zones of their stars. Some of those planets should have liquid water. Some should have atmospheres. And some, at least a few, should have developed life. But finding life is hard. Even if life is common in the universe, detecting it is incredibly difficult. Consider this: the closest star to us, Proxima Centauri, is more than 4 light-years away. If there were an alien civilization on a planet orbiting Proxima Centauri, and they were broadcasting radio signals into space, it would take more than 4 years for those signals to reach us. And then it would take another 4 years for our reply to reach them. That is an 8-year round trip for a simple message. And that is assuming the aliens are broadcasting at frequencies we can detect, and that their signals are strong enough to reach us across 4 light-years of space. Most radio signals fade and weaken as they travel through space, so by the time they reach another star system, they might be indistinguishable from background noise. And Proxima Centauri is the closest star. Most stars are much, much farther away. The average distance between stars in our part of the galaxy is about 5 light-years. So if you wanted to search for alien civilizations, you would need to listen to thousands of stars for years or even decades, hoping to catch a signal. And even if you did catch a signal, it might have been sent hundreds or thousands of years ago. The civilization that sent it might be long gone by the time we receive it. This is one of the great challenges of searching for extraterrestrial life. The distances are so vast and the timescales are so long that even if aliens exist, we might never find them. But that has not stopped us from trying. Scientists have been searching for extraterrestrial intelligence for more than 60 years. They use radio telescopes to listen for signals from space, hoping to detect a pattern or a message that could not be produced by natural phenomena. So far, they have found nothing conclusive. There have been a few tantalizing hints, like the famous WOW signal detected in 1977, but none of them have been confirmed. The search continues, and with each passing year, we scan more stars, listen to more frequencies, and refine our techniques. Maybe one day we will find something, a signal, a message, proof that we are not alone. Or maybe we will not. Maybe Earth is unique, a rare jewel in a universe filled with lifeless rocks. We do not know. And that uncertainty is part of what makes the search so compelling. Even if we never find intelligent aliens, we might still find simple life elsewhere in the solar system. Mars, for example, might have had life billions of years ago when it had liquid water on its surface. Today, Mars is cold and dry, but there might be microbes living underground, where conditions are more favorable. NASA has sent rovers to Mars to search for signs of past or present life, and they have found intriguing clues, like organic molecules and methane gas. These are not proof of life, but they are consistent with life. Similarly, some of the moons of Jupiter and Saturn might have life. Europa, one of Jupiter's moons, has a thick layer of ice covering a global ocean of liquid water. Beneath that ice, there might be hydrothermal vents, similar to the ones on Earth's ocean floor, where life thrives in the absence of sunlight. Enceladus, one of Saturn's moons, has geysers that spray water vapor and ice particles into space. That water comes from an underground ocean, and it contains organic molecules. These moons are some of the most promising places to search for life in our solar system. But even if we find life on Mars or Europa or Enceladus, it will probably be simple life. Microbes, bacteria, maybe something more complex, like algae or fungi, but probably not fish or trees or anything resembling animals. Complex life is rare even on Earth. For most of Earth's history, the only life was microbes, single-celled organisms that lived in the oceans and on the land, slowly changing the planet. It was not until about 600 million years ago that complex life appeared. Animals, plants, fungi, all the things we think of as life are relatively recent arrivals. Before that, Earth was a world of microbes, and it might be the same on other planets. Life might be common, but complex life might be rare. Intelligence might be even rarer. So even if we find microbes on other worlds, it does not mean we will find civilizations. This brings us back to the question of Earth's significance. If life is common, then Earth is just one of many worlds where life exists. But if life is rare, then Earth is special. And if intelligent life is rare, then Earth is even more special. We might be one of the few places in the universe where beings have evolved, who can look up at the stars and ask questions, who can build telescopes and spacecraft, who can do science and create art. That is a profound thought. It means we have a responsibility, not just to ourselves, but to the universe. We are the universe's way of understanding itself. We are the cosmos looking back at itself, trying to figure out how it works. And that makes what we do matter. It matters that we explore. It matters that we ask questions. It matters that we seek knowledge. Because if we do not, no one else will. We are the only ones, as far as we know, who can do this. The universe does not care what happens to us. It will continue on expanding and evolving, whether we are here or not. But we care. We care about understanding the universe. We care about finding our place in it. And that caring is what makes us special. Not because we are big or powerful or important in a cosmic sense, but because we are curious, because we want to know. And that desire to know is one of the most beautiful things about being human. Let us think more about time. We have talked a lot about distance, about how far things are from each other. But time is just as important. The universe is not just big in space. It is also big in time. The universe is 13.8 billion years old. That is an almost incomprehensible amount of time. To put it in perspective, if you condense the entire history of the universe into a single year, with the Big Bang happening at the stroke of midnight on January 1st, then the solar system would not form until September. Life on Earth would not appear until late September. Dinosaurs would not show up until late December. And humans, modern humans, would not appear until the last few minutes of December 31st. All of recorded human history, everything from the ancient Egyptians to the present day, would fit into the last few seconds before midnight. That is how young we are in cosmic terms. We are newcomers to the universe, latecomers to the party. The Big Bang is the moment when the universe began. Before the Big Bang, there was no space, no time, no matter, no energy. There was nothing, or at least nothing that we can understand or describe with our current physics. Then, 13.8 billion years ago, something happened. The universe exploded into existence from a single infinitely dense point. In the first fraction of a second, the universe expanded faster than the speed of light, growing from smaller than an atom to the size of a galaxy in an instant. This period is called inflation, and it is one of the most important moments in the history of the universe. After inflation, the universe continued to expand, but at a slower rate. It was incredibly hot and dense, filled with a soup of particles and energy. Over the next few 100,000 years, the universe cooled, and those particles began to come together to form atoms. First hydrogen, the simplest element, then helium, the second simplest. These were the only elements in the early universe. For a long time, the universe was dark. There were no stars, no galaxies, no light. Just a nearly uniform cloud of hydrogen and helium gas slowly cooling and expanding. Then, about 200 million years after the Big Bang, something changed. Gravity began to pull the gas together, forming clumps. Those clumps became denser and hotter, until finally they were hot enough for nuclear fusion to begin. And when that happened, the first stars were born. These first stars were massive, much bigger than the sun. They burned hot and bright, but they did not last long. After only a few million years, they exploded in supernovas, scattering the elements they had created across space. Those elements, like carbon and oxygen and iron, became part of new clouds of gas, which eventually formed new stars. And those new stars also exploded, enriching the universe even further. This cycle repeated over and over again, creating more and more heavy elements, until finally, the universe was rich enough in elements to form planets. And on at least one of those planets, life emerged. This is the story of the universe. It started with nothing, or almost nothing, and over billions of years, it grew and evolved into the incredibly complex, beautiful cosmos we see today. Galaxies, stars, planets, life, all of it came from that initial explosion 13.8 billion years ago. And it is still evolving. The universe is not static. It is dynamic, constantly changing, constantly creating new structures and destroying old ones. Stars are born and die. Galaxies collide and merge. Black holes consume matter and grow larger. And all the while, space itself is expanding, carrying everything farther and farther apart. One day, in the distant future, the universe will be very different from what it is today. In about 4.5 billion years, the Milky Way and Andromeda will collide, forming a new galaxy. Around the same time, the Sun will begin to die. It will swell up into a red giant, engulfing Mercury and Venus, and possibly Earth. The oceans will boil away. The atmosphere will be stripped off. And eventually the Sun will shrink down into a white dwarf, a small dim ember that will glow faintly for trillions of years. Earth, if it survives, will be a lifeless, frozen rock, orbiting a dead star. That is the fate of our solar system, but it is not the end of the universe. Other stars will continue to shine. New stars will continue to form, and the universe will keep expanding. But even the stars will not last forever. The universe is constantly running down, losing energy. Every time a star shines, it converts mass into energy, and that energy radiates out into space, never to be recovered. Over trillions of years, the supply of hydrogen and helium will run out. No new stars will form. The existing stars will burn out one by one, leaving behind white dwarfs, neutron stars, and black holes. Eventually, the universe will be filled with these dead remnants, drifting through the darkness, and even the black holes will not last forever. Through a process called Hawking radiation, black holes slowly evaporate, losing mass until they finally disappear. This process takes an unimaginably long time, far longer than the current age of the universe. But eventually, given enough time, even the black holes will be gone. And then the universe will be truly dead. No stars, no galaxies, no light. Just a cold, dark, empty expanse, filled with nothing but stray particles and the faint glow of leftover radiation. This is called the heat death of the universe, and it is the most likely fate, based on what we currently know. But that is trillions upon trillions of years in the future. For now, the universe is young and vibrant, filled with light and life. Stars are shining, galaxies are spinning, planets are orbiting, and on at least one of those planets, beings have emerged who can look up at the sky and wonder. That is where we are now. This is our moment, and it is a moment worth savoring. Let us return to Earth. After this long journey through the universe, after zooming out from our planet to the solar system, to the galaxy, to the superclusters, to the edge of the observable universe, let us come back home. Earth is still here, still orbiting the sun, still spinning on its axis, still covered with oceans and continents and clouds. From this perspective, after seeing the vastness of the cosmos, Earth looks different. It looks smaller, more fragile, but it also looks more precious, because it is home. It is the only home we have ever known, and it is the only place in the universe where we know for certain that life exists. When astronauts go into space and look back at Earth, they often describe a feeling called the overview effect. It is a profound shift in perspective that comes from seeing Earth as a whole, from seeing it floating in the darkness of space, with no borders, no divisions, just one small, beautiful world. Astronauts who have experienced the overview effect often say it changed them. It made them realize how fragile Earth is, how interconnected we all are, and how important it is to take care of the planet. Because there is no backup, there is no other Earth. If we ruin this one, we have nowhere else to go. Earth is about 4.5 billion years old. It formed from the leftover material after the sun was born, a swirling disk of gas and dust that slowly clumped together to form planets. For the first few 100 million years, Earth was a hellish place. The surface was molten rock, constantly bombarded by asteroids and comets. There was no atmosphere, no oceans, no life, just a hot, violent ball of lava. But over time, the bombardment slowed, and the surface began to cool. Water vapor in the atmosphere condensed and fell as rain, forming the first oceans. And somewhere in those ancient oceans, something incredible happened. Life emerged. We do not know exactly how it happened. We do not know if it started in a tide pool, or near a hydrothermal vent, or somewhere else entirely. But somehow simple molecules came together and formed the first living cells. And those cells began to reproduce, passing on their genetic information to the next generation. That was the beginning of life on Earth. For billions of years, life was simple. Just microbes, living in the oceans, slowly evolving, slowly changing the planet. Those microbes invented photosynthesis, the ability to convert sunlight into energy. And as a byproduct of photosynthesis, they released oxygen into the atmosphere. At first, the oxygen was absorbed by rocks and iron in the oceans. But eventually, the oxygen began to build up in the atmosphere. This was a disaster for many of the early microbes, which could not survive in an oxygen-rich environment. But it was also an opportunity. Some organisms evolved to use oxygen for energy, and those organisms were much more efficient than the ones that came before. They could grow larger, move faster, and colonize new environments. Over time, these oxygen-breathing organisms gave rise to all the complex life we see today. Plants, animals, fungi, All of us are descendants of those early microbes that learned to breathe oxygen. The history of life on Earth is a story of constant change. Species appear, evolve, and go extinct. Ice ages come and go. Continents drift across the surface of the planet. Asteroids strike, causing mass extinctions. And through it all, life persists, adapting to whatever the planet throws at it. Humans are just the latest chapter in this story. We have only been around for about 300,000 years, a tiny fraction of Earth's history. But in that short time, we have had an enormous impact. We have spread across the entire planet. We have built cities and roads and farms. We have changed the landscape, altered the climate, and driven countless species to extinction. For better or worse, we have become a dominant force on Earth. And that comes with responsibility. We have the power to protect the planet or to destroy it. The choice is ours. Right now, Earth is facing serious challenges. The climate is changing, driven by human activity. Temperatures are rising, ice caps are melting, sea levels are rising. Extreme weather events are becoming more common, and ecosystems are being disrupted. Many species are struggling to adapt, and some are going extinct. This is a crisis, and it is one of our own making. But it is also a crisis we can solve if we act now. We have the technology to reduce carbon emissions, to protect forests, to conserve water, and to transition to renewable energy. What we need is the will to do it. We need to recognize that Earth is not just a resource to be exploited. It is our home. And if we want future generations to have a home, we need to take care of it. Taking care of Earth is not just about environmentalism. It is about recognizing our place in the universe. We are not separate from nature. We are part of it. We are made of the same atoms as the rocks and trees and oceans. We breathe the same air. We drink the same water. We are all connected, part of a single living system. And when we harm the planet, we harm ourselves. This is not a metaphor. It is a fact. The health of the planet and the health of humanity are intertwined. We cannot have one without the other. And yet, despite all the challenges we face, there is also reason for hope. Humans are capable of incredible things. We have split the atom, mapped the human genome, and sent spacecraft to the outer reaches of the solar system. We have built telescopes that can see back to the beginning of time, and computers that can process trillions of calculations per second. We have created art and music and literature that move the soul. We have built civilizations, cured diseases, and connected billions of people across the globe. If we can do all that, then surely we can solve the problem of climate change. Surely we can find a way to live sustainably on this planet. It will not be easy. It will require sacrifice and cooperation and innovation. But it is possible, and it is necessary. One of the most important things we can do is to remember our place in the universe. When you understand how vast the cosmos is, when you see how small Earth really is, it puts things in perspective. The problems that seem so insurmountable start to feel more manageable, not because they are less important, but because you realize that we are all in this together. We are all passengers on the same small planet, hurtling through space. Our differences, the things that divide us, they seem less significant when you see Earth from space. There are no borders visible from orbit, no countries, no nations, just one world, one humanity, sharing one fragile home. That is the message of the overview effect, and it is a message we need to take to heart. We also need to remember that we are part of something much larger. We are part of the universe. We are made of stardust, forged in the hearts of ancient stars. The carbon in our bodies, the oxygen we breathe, the calcium in our bones, all of it was created billions of years ago in the fiery cores of dying stars. When those stars exploded, they scattered those elements across the galaxy, and eventually, some of those atoms came together to form Earth, and life, and us. In a very real sense, we are the universe looking at itself. We are a small part of the cosmos that has become conscious, that has opened its eyes and looked around and said, I am here, I exist, I want to understand. And that is extraordinary. This connection to the universe is not just poetic, it is literal. Every atom in your body has a history that stretches back billions of years. The hydrogen atoms in your body, for example, were formed in the Big Bang 13.8 billion years ago. They have been around since the very beginning of the universe. They have floated through space, been part of clouds of gas and dust, been inside stars, and now they are part of you. You are not separate from the universe. You are part of it. You are the universe experiencing itself, and that makes you, in a very real way, a miracle. Not because you are special in some cosmic sense, but because you are improbable. You are the result of billions of years of cosmic evolution, an unbroken chain of events stretching back to the beginning of time. And here you are, alive, conscious, aware. That is something worth celebrating. It is also something worth protecting, because if we destroy Earth, if we make it uninhabitable through our own actions, then we are not just destroying our home. We are destroying one of the rarest things in the universe, a place where life exists, a place where the universe has become aware of itself. That is a tragedy beyond measure, and it is one we have the power to prevent. We have the knowledge. We have the advanced technology. What we need is the will. We need to choose to act, to take responsibility for the planet we have been given, to be good stewards of this small, beautiful world. Now, let us think about the future. What happens next? Where do we go from here? Humanity has always been a species of explorers. We spread out of Africa tens of thousands of years ago, colonizing every continent except Antarctica. We crossed oceans in small boats, not knowing what lay on the other side. We climbed the highest mountains, explored the deepest caves, and ventured into the most inhospitable deserts. Exploration is in our nature, and now we are beginning to explore space. We have sent humans to the moon. We have sent robots to Mars. We have probes exploring the outer solar system, and one spacecraft, Voyager 1, has even left the solar system entirely, venturing out into interstellar space. These are small steps, but they are steps nonetheless. And they point to a future where humanity might one day spread beyond Earth, colonizing other worlds, building new civilizations among the stars. But that future is still a long way off. For now, we are stuck here on Earth. We do not have the technology to travel to other star systems. We do not even have the technology to build a self-sustaining colony on Mars. Getting to Mars is one thing. Living there permanently is something else entirely. Mars has no breathable atmosphere, no liquid water on the surface, and no magnetic field to protect against radiation. Anyone living on Mars would need to live in sealed habitats, relying on technology for every breath of air and every drop of water. It would be a harsh, difficult existence, and it would take decades, maybe centuries, to build the infrastructure needed to support a large population. So for the foreseeable future, Earth is our only home, and that means we need to take care of it. But that does not mean we should stop exploring. Exploration is how we learn. It is how we grow. and it is how we ensure our long-term survival as a species. Earth is a wonderful place, but it is also vulnerable. Asteroids strike planets all the time. Supernovas can bathe nearby star systems in deadly radiation. Even the sun will eventually die, making Earth uninhabitable. If humanity wants to survive in the long term, we need to become a multi-planetary species. We need to spread out, to establish colonies on other worlds, so that if something happens to Earth, we are not all wiped out. This is not about abandoning Earth. It is about ensuring that the incredible story of life on Earth does not end with us. And maybe, just maybe, we will one day find other life in the universe. Maybe we will discover microbes on Mars, or fish swimming in the oceans of Europa, or even intelligent civilizations on planets orbiting distant stars. If that happens, it will be one of the most profound moments in human history. It will change the way we see ourselves and our place in the universe, because if we find life elsewhere, it means we are not alone. It means the universe is teeming with life, that Earth is just one of countless worlds where the conditions were right for life to emerge. And that would be a beautiful thing, because it would mean that the universe is not a cold, dead place. It is alive, it is vibrant, it is full of possibilities. But even if we never find other life, even if we are alone, that is also a profound realization, because it means that life is rare. It means that Earth is special. It means that we have something precious, something that might not exist anywhere else in the universe, and that makes it all the more important to protect it. Whether we are alone or not, Earth is our home, and it is the only home we have. So where does that leave us? What is the takeaway from all of this? What should you do with the knowledge that Earth is unimaginably small, that the universe is vast beyond comprehension, and that we are all made of stardust? The answer is simple. Live. Live your life. Appreciate the small things. The warmth of the sun on your face, the smell of rain, the sound of laughter, the feeling of love. These things might not matter to the universe, but they matter to you, and that is enough. You do not need to be important on a cosmic scale to matter. You just need to matter to someone, to yourself, to your family, to your friends, to the people whose lives you touch. Let us take one more moment to truly understand what we have explored here today. We began on the surface of Earth, standing on solid ground, surrounded by familiar things. The sky above, the ground below, the horizon in the distance. Everything felt real and tangible and knowable. But then we started to zoom out. First, we rose above the surface and saw our city, then our country, then our entire planet floating in space. That was the first shift in perspective. Earth, which had seemed so large and stable, suddenly looked small and fragile. Then we compared Earth to its neighbors. Venus and Mars, similar in size, made Earth feel less unique. But Jupiter, that massive giant, made Earth look tiny. And the Sun, our star, made Earth look like an invisible speck. We had started to understand scale, to grasp just how small our planet is compared to the objects around it. But we were still in our own solar system, still in familiar territory. The real shock came when we ventured beyond, when we crossed the vast emptiness between the Oort cloud and the nearest star. Something changed. The distances became so large that they stopped making sense. 4 light years, 25 trillion miles, numbers so big that the human brain cannot truly comprehend them. And that was just to reach our closest neighbor. The other stars in our galaxy are even farther away, scattered across the void like islands in an endless ocean. Each one of those stars might have planets. Each one of those planets might have moons. And some of those worlds might even have life. But we cannot know because they are so far away that reaching them with our current technology is impossible. Then we zoomed out even more, and the Milky Way came into view. Our galaxy, with its hundreds of billions of stars, its spiral arms, its central black hole, its vast clouds of gas and dust. From this perspective, our sun was just one star among countless others. Earth was not even visible. It had disappeared into the cosmic background, lost among the billions of other worlds that orbit the billions of other stars in our galaxy. And we realized that the Milky Way, as vast as it is just one galaxy among many. Andromeda appeared next, another spiral galaxy, even larger than our own, with 1 trillion stars. And then the local group, a small cluster of galaxies, including the Milky Way and Andromeda, and dozens of smaller galaxies, all held together by gravity. From this distance, galaxies looked like tiny points of light. The Milky Way, which had seemed so enormous just moments before, was now just one small light among many. And the space between the galaxies was vast, dark, and empty. Light took millions of years to cross from one galaxy to another. The distances were so great that they defied imagination. And still, we zoomed out further. The Virgo supercluster came into view, a massive structure containing thousands of galaxies, including our entire local group. And then Laniakea, an even larger supercluster containing tens of thousands of galaxies, all flowing toward the Great Attractor. And finally, the cosmic web, the largest structure in the universe, a vast network of filaments and voids stretching across hundreds of millions of light years. From this perspective, superclusters looked like tiny nodes in a giant web. The Milky Way was completely invisible. Earth was beyond invisible. It had become less than nothing, less than a speck, less than a grain of sand. It had become an abstraction, a mathematical point in an inconceivably vast cosmos. And then we reached the edge of the observable universe, 93 billion light years across, containing 2 trillion galaxies. This is the limit of what we can see, the boundary beyond which light has not had time to reach us. Beyond this edge, the universe continues, perhaps forever. But we cannot see it. We cannot know what is there. We are trapped inside our own cosmic horizon, forever limited by the speed of light and the expansion of space. And even within the observable universe, even within this vast structure containing 2 trillion galaxies, Earth is still invisible. It is so small that it cannot be shown on any map, cannot be represented by any pixel, cannot be described by any analogy that makes sense to the human mind. Earth is, for all intents and purposes, nothing. And yet, Earth is also everything. It is the only place we know of where life exists. It is the only place where the universe has become conscious, where matter has organized itself into beings capable of looking up at the stars and asking questions. What are we? Where did we come from? What does it all mean? These questions might seem small and insignificant in a universe this vast, but they are also profound, because asking them means we care. It means we are not content to simply exist. We want to understand. We want to know our place in the cosmos. And that desire to understand is one of the most beautiful things about being human. We live in a time when we can answer some of these questions. We have telescopes that can see back to the beginning of time. We have spacecraft that can visit other planets. We have computers that can simulate the evolution of galaxies. We have built up a body of knowledge about the universe that would have seemed like magic to our ancestors. And yet, there is still so much we do not know. We do not know what dark matter is. We do not know what dark energy is. We do not know if there is life elsewhere in the universe. We do not know what lies beyond the edge of the observable universe. We do not know what happened before the Big Bang, or what will happen after the universe ends. There are mysteries everywhere waiting to be solved. And that is exciting, because it means there is always more to learn. Always another discovery waiting to be made. So even though Earth is small, even though we are small, we are also part of something much larger. We are part of the universe. We are made of atoms that were forged in the hearts of stars billions of years ago. We are connected to every star, every galaxy, every particle of matter in the cosmos through the shared history of the universe. We are not separate. We are not isolated. We are part of the whole. And that is a profound and beautiful thing. Think about this. The light from distant galaxies has been traveling through space for millions or even billions of years. When that light finally reaches Earth, when it enters your eye or hits the sensor of a telescope, it is completing a journey that started long before humans existed. That light has traveled across unimaginable distances, across voids and filaments, past countless stars and galaxies, just to reach you. In a very real sense, when you look up at the night sky, you are touching the universe. You are connecting with something vast and ancient and beautiful, and that connection is real. It is not a metaphor. The photons that hit your eye came from those distant stars. They are the same photons that left those stars millions of years ago. They have traveled through space and time to reach you. And in that moment, you are part of the universe, and the universe is part of you. This is why we explore. This is why we build telescopes and spacecraft and ask questions. Because we want to understand. We want to know our place in the cosmos. We want to connect with something larger than ourselves. And in doing so, we discover that we are not separate from the universe. We are part of it. We are the universe experiencing itself, looking back at itself, trying to understand itself. And that is extraordinary. It is a privilege. It is a gift. And it is something we should never take for granted. So the next time you feel small, the next time you look up at the night sky and feel overwhelmed by the vastness of space, remember this: you are small, but you are also part of something much larger. You are made of stardust. You are the product of billions of years of cosmic evolution. You are a miracle, an improbable collection of atoms that has somehow come together to form a living, thinking, feeling being. You are the universe's way of knowing itself, and that is something worth celebrating. Earth is small, unimaginably small, but it is also home. And as far as we know, it is the only home we have. So let us take care of it. Let us protect it. Let us cherish it. Because in a universe this vast, in a cosmos filled with trillions of galaxies and countless stars and endless voids, Earth is a rare and precious thing. It is a place where life exists, where consciousness has emerged, where beings can look up at the stars and wonder, and that makes it worth everything. There is something deeply humbling about understanding the scale of the universe. When you realize just how vast space is, just how many galaxies there are, just how old the cosmos is, it changes you. It makes you see the world differently. The things that once seemed so important, so urgent, so all-consuming, they start to seem smaller. Not less important, but smaller, more manageable. Because you realize that in the grand scheme of things, in the vast sweep of cosmic time, your problems are temporary. They are fleeting. They will pass. And what remains, what truly matters, is the time you have right now, the people you love, the moments you cherish. This does not mean your problems are not real. They are real, they matter to you, and they should matter. But it does mean that you can face them with perspective. You can step back, take a breath, and remember that you are part of something much larger. You are part of a universe that has been unfolding for 13.8 billion years. You are part of a planet that has been home to countless generations of life. You are part of a human story that stretches back hundreds of thousands of years. And you are also part of the present, the here and now, the brief moment when you exist and can make a difference. What kind of difference can you make? That depends on you. Maybe you will make a big difference, changing the world in some significant way. Or maybe you will make a small difference, touching the lives of a few people, making them smile, helping them through a difficult time. Both are important, both are valuable, because the universe is not just about the big things, the galaxies and stars and cosmic structures. It is also about the small things, the interactions between people. The moments of kindness and compassion, the love we share, these things might not register on the cosmic scale, but they register on the human scale. And that is what matters to us. So as we come to the end of this journey, as we return from the edge of the observable universe back to Earth, back to our lives, remember what we have learned. Remember that Earth is small. Remember that we are small, but also remember that we are part of something much larger. We are connected to the universe in ways we are only beginning to understand. We are made of stardust. We are the product of billions of years of cosmic evolution. We are the universe's way of knowing itself. And that is a beautiful, profound, and extraordinary thing. Look around you. Look at the world you live in. The trees and the rivers and the mountains, the cities and the roads and the buildings, the people walking by, each one with their own story, their own dreams, their own struggles. All of this exists on one small planet, orbiting one small star, in one small corner of one galaxy, in a universe filled with trillions of galaxies. And yet, it is also everything. It is your world. It is your life, it is your home, and it is worth protecting, worth cherishing, worth loving. So go out and live your life. Be kind to others. Take care of the planet. Look up at the stars and remember where you came from. Ask questions, seek knowledge, create beauty, spread joy. And remember that, even though you are small, you are also part of something much larger. You are part of the incredible, ongoing story of the universe. And that story is yours to write. What happens next is up to you. Choose wisely, choose kindly, and choose to make the most of the time you have. Because in a universe this vast, in a cosmos this old, the fact that you exist at all is a miracle. And that miracle is worth celebrating every single day. So how small is Earth really? It is smaller than you can imagine. It is a pale blue dot, floating in the vastness of space, invisible on the cosmic scale. And yet, it is also everything. It is home. It is where we live, where we love, where we dream. It is where the universe has become aware of itself. And that makes it the most important place in the universe. Not because it is big, but because it is ours. And we are part of it. And it is part of us. And together, we are part of the incredible, beautiful, mysterious cosmos. And that is something worth remembering every time you look up at the night sky and see those distant stars shining in the darkness. And remember that you are part of something much larger. You are part of the story of the universe. You are a collection of atoms that have journeyed across billions of years and trillions of miles to be here, to be you. You are the universe experiencing itself, looking back at itself, trying to understand itself. And that is a beautiful thing. So take a moment, every now and then, to look up at the stars, to remember where you came from, to appreciate the incredible, improbable fact that you exist at all, because you are a miracle, not because you are special, but because you are here. The universe is vast, it is old, it is filled with wonders we can barely imagine. Galaxies spinning in the darkness, stars being born and dying, planets orbiting in the habitable zones of their stars, black holes consuming matter and warping space and time, nebulae glowing with the light of newborn stars, supernovas exploding with the force of 1 billion suns. All of this is happening right now across the cosmos. And you are a part of it. You are connected to all of it through the atoms in your body, through the laws of physics that govern the universe, through the shared history of the cosmos. You are not separate. You are not alone. You are part of the whole. And that is something worth remembering. So how small is Earth really? It is so small that it is almost invisible on the cosmic scale. A pale blue dot floating in a sunbeam, lost in the vastness of space. It is smaller than a grain of sand compared to the observable universe. It is so small that if you tried to show it on a map of the universe, you could not. There would not be a pixel small enough. And yet, Earth is also everything. It is home. It is where we live. It is where we love and laugh and dream. It is where the universe has become aware of itself. And that makes it special. Not because it is big, but because it is ours. And maybe that is the most important lesson. Size does not matter. Importance is about what you do with the time you have. It is about the connections you make, the love you share, the joy you create. It is about the small moments that make life worth living. The smile of a friend, the beauty of a sunset, the feeling of accomplishment when you finish something difficult. It is about the connections you make, the love you share, the joy you create. It is about the small moments that make life worth living. The smile of a friend, the beauty of a sunset, the feeling of accomplishment when you finish something difficult. These things are what matter, not because they change the universe, but because they change you. And in changing you, they change the small corner of the universe that you touch. So take care of each other. Take care of the planet. Look up at the stars and remember your place in the cosmos. Be curious. Ask questions. Seek knowledge. Create beauty. Spread joy. And remember that even though you are small, you are also part of something much larger. You are part of the incredible, ongoing story of the universe. And that story is still being written. What happens next depends on what we do now, on the choices we make, on the actions we take. We have the power to shape the future, to determine what the next chapter of the human story will be. Will it be a story of cooperation and exploration and growth? Or will it be a story of division and destruction? The choice is ours, and the time to choose is now. The universe does not care what we do. It will keep expanding, keep evolving, keep creating new stars and galaxies, whether we are here or not. But we care. We care about the future. We care about the planet. We care about each other. And that caring is what makes us human. It is what makes us special. Not our size, not our power, but our ability to care, to love, to wonder, to ask questions, to seek meaning in a vast and often indifferent cosmos. That is what makes us worth preserving. That is what makes Earth worth protecting. And that is what makes this journey, this brief moment of existence on a small planet, orbiting an average star in a typical galaxy, worth celebrating. So celebrate it. Celebrate the fact that you are here, that you are alive, that you get to be part of this incredible universe. Look around you. Appreciate the beauty of the world, the complexity of life, the vastness of space, and know that you are a part of all of it. You are made of stardust. You are the universe looking at itself. And that makes you, in a very real way, extraordinary. Not because you are big or powerful or important in a cosmic sense, but because you are here, you exist, you are aware, and in a universe that is vast and cold and mostly empty, that is something truly remarkable. Thank you for joining us on this journey through the cosmos. Thank you for taking the time to think about your place in the universe, to consider the scale of everything, to appreciate the smallness of Earth and the vastness of space. If you enjoyed this exploration, if it made you feel something, if it changed the way you see the world, even just a little bit, then please come back and join us again on Cosmic Drift. We will be here, exploring the wonders of the universe, one journey at a time. Until then, take care of yourself, take care of each other, and take care of our small, beautiful planet, because it is the only one we have.